Currently, the whole world is developing new energy vehicles, and many countries have accelerated the phase-out of gasoline vehicles. However, the major drawback of poor endurance of new energy vehicles has become a bottleneck. As a result, car manufacturers have come up with the idea of using nuclear power. Audi unveiled a concept car named Mesarthim-F-Tron Quattrod 2 years ago. This car was originally designed by a Russian and caught the attention of Audi. If there's anyone in the world daring enough to put a nuclear reactor in a car, it would definitely be the warrior nation. Let's first take a look at its advantages. Many people may not know that the endurance of nuclear-powered vehicles can be described as ultra-long standby. The second-generation nuclear-powered aircraft carrier of the U.S. military can operate for 13 years on a single fueling, covering a distance of nearly 2 million kilometers. This car, at least with one refueling, could run for 20 years without any issues. Additionally, its straight-line acceleration to a top speed of 500 kilometers per hour requires the use of ejection seats to prevent G-forces. Of course, it faces quite serious problems, such as nuclear pollution. Once a leak occurs, the consequences would be unimaginable. Although Audi claims that this car will use aerospace-grade sturdy materials, there are still concerns about potential accidents and leaks. After all, this is a significant hidden risk. Some netizens have pointed out that it would be terrifying if terrorists were to use these cars for malicious purposes. Indeed, for a product with such clear advantages, caution should be exercised. What do you all think? This video introduces the nuclear-powered cars that briefly appeared in the history of the automotive industry. They were developed as early as the mid-20th century and gained considerable fame. 1. Studebaker Packard Astral, star, possibly the earliest attempt at a concept car, 1957. This brand is likely unfamiliar to most people because it disappeared in the 1960s. At the time, it was a formidable presence alongside Cadillac. However, when it couldn't compete, it took a different route and introduced the Astral concept car. This vehicle had only one wheel, maintained balance through a gyroscope, and could even travel on water. Packard claimed it was equipped with a nuclear-powered engine and featured a protective energy shield generated by a force field to prevent nuclear leaks. It sounded like alien technology. But the official presentation did not reveal its nuclear-powered engine. Given its slim design, it likely was just a concept car. 2. Arbel Symmetric gained the attention of the military, 1958. Initially featuring an extended-range hybrid system, it appeared at the Paris Motor Show in 1951. However, the French were not interested in this car, as hybrid or fully electric vehicles were not uncommon at the time, given that there were already pure electric cars in 1897. Nevertheless, the Symmetric caught the attention of the military, claiming to introduce a model equipped with a maximum power 40 kilowatts nuclear power generator capable of running continuously for 5 years. However, the company ceased operations the following year, and nothing further came of it. 3. Ford Nucleon concept, only a model, no prototype, 1958. The 1950s marked the beginning of the United States development of nuclear-powered aircraft carriers, and this trend also extended to the automotive industry. Apart from the two aforementioned cars, Ford also intended to enter this field. In 1958, it unveiled the Nucleon concept car, which was merely a scale model without a prototype. Ford, however, invested some effort in nuclear power research. The Nucleon's nuclear reactor was placed at the rear of the car, generating heat by splitting uranium to heat water into steam, which then drove a turbine to power the vehicle. Due to unresolved technical challenges, it never entered into actual production. 4. Simca Fulgur, still futuristic by today's standards, 1958. Even by today's standards, this car can still leave you speechless for a few seconds. It was the work of renowned designer Robert Opron and featured numerous functions that were ahead of its time: electromagnetic suspension, artificial intelligence-like technology, partial autonomous driving, and navigation functions. There's controversy surrounding its power source, with some claiming it used hydrogen fuel cells and others suggesting it was nuclear-powered. This car remained at the concept stage and vanished from the automotive stage with the brand's closure. 5. Ford Seattleite Xxi, audience more interested in the six wheels, 1962. After shelving the Nucleon project in 1958, Ford didn't give up. For years later, they introduced the nuclear-powered Seattleite Xxi. Again, it was just a model. The engine compartment at the front could switch between fuel cells and a nuclear reactor for power. Perhaps due to audiences hearing too many boy who cried wolf stories in the 1950s, there wasn't much attention on its nuclear power after its debut. Instead, people were more interested in its six wheels. Ultimately, it met the same fate and was put on the back burner. 6. Cadillac Thorium concept, using thorium, theoretically safer than uranium, 2009. This car was designed by someone known for designing skateboards and guitars, so the appearance was unconventional. I even questioned how one would get into the car, perhaps by crawling in from underneath. True to its name, it used a thorium-based nuclear reactor as its power source. With just around 8 g of thorium, the car could travel approximately 1.61 million kilometers, enough to last at least 50 years based on average annual mileage for a household car, with surplus energy that could be fed back into the grid. While theoretically safer than uranium due to the use of thorium, it's still a radioactive element. Most people were against it, and this car naturally remained at the concept stage. 7. Audi Mesarthim-F-Tron Quattrod, claimed to have achieved nuclear fusion, 2014. This car had a detailed design and even showcased internal structural diagrams. The nuclear reactor was positioned in the middle and rear of the car, and it still worked on the principle of boiling water to generate electricity through steam, ultimately driving 4 hub motors. Audi claimed to have successfully achieved nuclear fusion to generate energy. However, due to the inability to address nuclear radiation and waste disposal, this concept car disappeared from the scene thereafter. The difficulties of nuclear-powered cars lie in several key areas. Over the past half-century, most nuclear-powered cars have remained at the conceptual stage, and the challenges of this technology are significant. Firstly, there is the issue of size. While the core of a nuclear reactor is not large, the entire system, including nuclear fuel, cooling systems, water circulation systems, protective facilities, safety redundancy measures, steam circulation systems, turbines, generators, and more, adds up to a considerable volume. It's not something that can be accommodated in a household car, let alone a bus. Secondly, there is the challenge of nuclear protection. Currently, there isn't a good method for protecting against nuclear radiation. The mainstream approach involves adding protective shielding, but even for a small reactor, the specifications for the shielding are at least several tons. Moreover, even with such shielding, there's no guarantee that the nuclear reactor inside a vehicle would remain unscathed in the event of an accident. If a nuclear-powered car were to experience a leak in a busy city, the consequences would be significant. Some may argue that there are nuclear batteries now, such as those used in the Curiosity rover on Mars. However, current nuclear batteries are only used for low-power applications. For example, plutonium batteries have an output power density of 0.41 watts per gram. A typical household car requires at least 100 kilowatts of power, which would necessitate over 200 kilograms of plutonium, along with other materials and substantial lead shielding for nuclear protection. The battery pack alone would easily weigh over a ton. If one were to pursue high performance, as seen in many electric cars today easily surpassing 300 kilowatts, the weight of the nuclear battery pack would approach 3 tons, which is not practical. Lastly, there is the issue of cost. The Curiosity rover used approximately 45 kilograms of plutonium, costing millions of dollars. For a household car, 45 kilograms would definitely not be enough and would require additional expense. Even if one were financially capable, spending hundreds of millions of dollars would only result in a car that doesn't meet highway speed standards. Is that something one would be willing to accept? In conclusion, Chinese car companies have conducted relatively little research on nuclear-powered cars. Chery once applied for a trademark in 2018, including fuel and nuclear moderator handling devices, nuclear fuel and nuclear moderator handling devices, fusion reaction equipment, nuclear reactors, atomic piles, nuclear reactors, atomic reactors, in its goods/services category. However, based on Chery's recent development, nuclear-powered cars seem to be more of a pipe dream and have not been practically pursued. In 1905, Einstein proposed the mass-energy equation E equals mc in his theory of special relativity. In 1945, two catastrophic nuclear explosions occurred in Japan, after which nuclear energy became a lifelong pursuit for many countries. It is well known that nuclear energy is a double-edged sword. When used well, it can benefit future generations, but when used poorly, it can cause harm for millennia. Currently, nuclear energy can only be applied in non-civilian fields such as aerospace, navigation, and power generation. Hopefully, in the not-too-distant future, a superior energy source to fossil fuels and electricity will emerge, igniting another revolution in transportation.